Throughout the ages, man's comfort and economic progress have depended on fuel. And as man has advanced from the primeval swamp to the modern city, his demand for fuel has increased. But fuel is a wasting asset. The miner digs deeper into decreasing reserves. Axe and fire and erosion turn field and forest into desert. Hence the unrelenting search for more fuel, more powerful, cheaper, cleaner, probing earth and sea. In the last century, they found oil, and with it gas, natural gas. For years, flared off to waste, knew what else to do with it. Even later, when a use for it was discovered, it was confined to the country of origin, because no way had yet been devised of transporting it overseas. Until 1951, when William Wood Prince, a Chicago stockyards executive, designed a special barge to carry condensed natural gas from his gas fields in Louisiana up the Mississippi River to use in place of expensive local gas. This suggested to the British gas industry a solution to a growing problem, its dependence on coal. For a century and a half, coal had been the main raw material for the production of town gas. But with rising costs and increasing competition, new methods and other feedstocks had to be found. The search for natural gas in the United Kingdom had been going on for some time, but with only small success. If natural gas was to be available to the British gas industry, ways and means would have to be found of transporting it from more plentiful sources overseas. At the instigation of the Gas Council, Michael Milne Watson, chairman of the North Thames Gas Board, investigated the problem. And in the United States in 1957, Comstock International Methane of New York were joined by the British gas industry to put all the years of experiment and research to the ultimate test. At Mobile, on the Gulf of Mexico, they converted a dry cargo ship, renamed the Methane Pioneer, specially designed to carry natural gas by sea. The dramatic moment came at Lake Charles on January the 30th, 1959, when at last the Methane Pioneer set sail. Destination, Canvey Island, across 5,000 miles of sea. At Canvey, prototype methane storage tanks stood ready and waiting, while the tanker battled delaying storms. And critics on both sides of the Atlantic were saying she would never reach her destination. But on February the 20th, 1959, the Methane Pioneer arrived. In her insulated holds, 2,000 tons of liquid natural gas, the first seaborne natural gas in the world. A way had been found. So the 8 years of experiment and perseverance ended in triumph, and a new chapter in the history of world energy began. At this time, world reserves of natural gas were estimated at over 700 million cubic feet. At least 35 million were in Algeria, at Hassi Armel. Less than 10 years ago, an empty, arid wilderness in the heart of the Sahara Desert. Like a charred, lunar landscape in outer space. Suddenly, the third biggest gas field in the world. Hassi Armel means lucky well. Lucky for Algeria, who needed the assets. Lucky for Britain, who wanted the gas. In November 1961, the Minister of Power approved a contract to import 3,500 million cubic feet of Algerian gas annually. The stage was set for the plan to go forward. At the London headquarters of the Gas Council, an operations room was set up to record progress on the biggest project of its kind this country had ever known, starting nearly 2,000 miles away in the heart of the Sahara Desert. This was the plan. From the wellhead at Hassi Armel, there was already a pipeline to the coast at Arzew. At Arzew, a plant to be built to liquefy the methane gas for transportation in 2 British-built methane tankers across the 1,500 miles of sea to Canvey Island. At Canvey, a marine terminal to change the liquid back into gas and pump it out into the 350-mile pipeline from Canvey to Leeds. The schedule for this huge project was just 2 years. Arzew. At the start of the methane project, a small port, suspended in time and space like a mirage between Algiers and Oran. In a country where past and present rub shoulders, as at some crossroad in history, where car and plane compete with the still surviving camel. This ancient world, now suddenly confronted with the 20th century, in the shape of the biggest gas liquefaction plant in the world. What the coming of natural gas would mean to the people of Arzew, time alone would tell. Not least, the time paid out in dinars. For the Port Authority at Arzew, it meant dredging and new jetties to refashion the shallow harbor into a loading station for ocean-going tankers. For Sea Algérienne du Methane Liquide, it meant building the liquefaction plant, some of it on land reclaimed from the sea. 3 special storage tanks above ground to store a total of 18,000 tons of sub-zero liquid gas. And underground, another 18,000 tons, in what is basically just a huge pre-frozen hole in the ground, its icy walls kept sealed and safe by the cold gas inside. And finally, the building of the actual liquefaction plant. To freeze every 600 cubic feet of gas down to an incredible 258 degrees below, at which it liquefies and shrinks to a single cubic foot of liquid. The enormous reduction in volume made it practical and economic to transport natural gas by sea. At Vickers Shipyard, Barrow-in-Furness, the keel of the first methane tanker was laid in June 1962, exactly a year before the scheduled launching date. At Harland & Wolff, Belfast, the keel of the second tanker was laid 4 months later. Both tankers built to the same secret and world-patented design, putting into effect the experience gained in the earlier trials across the Atlantic of the methane pioneer. The special features of the new tankers, the first in the world specially constructed for the transportation of natural gas, were ingenious and unique. The ship's engines, with up to 60% of the driving power supplied by the evaporation from the liquid gas in the cargo tanks. A double hull for greater strength and safety. The balsa wood from faraway Ecuador to line the 3 holes. This not only insulates the cold gas against external heat, but also acts as a secondary barrier in the unlikely event of the gas escaping. The 9 aluminium cargo tanks, which remain ductile and safe where steel would harden and split. By any standards, tankers as safe as any ship that sails the 7 seas. If there was one project more fraught with problems than building tankers to transport something as cold and volatile as liquid natural gas, it was constructing an 85-acre terminal to handle it when it arrived. 12,000 tons per week. The jetty, 750 feet long, standing on 300 concrete piles. Like teeth, driven firmly into the river's mouth. On the site itself, more piles. To permit a free passage of frost-preventing air between the ground and the cold storage tanks above. 5 storage tanks, the outer casing made of steel. The inner tank, which actually holds the liquid gas, made of aluminium alloy. Between the two, a special insulation to keep the gas at the necessary low temperature. Welding the aluminium had its problems too, requiring special techniques and flawless workmanship, with 100% radiographic check. Finally, the 3 evaporators, which with the aid of the water from the adjoining estuary, convert the liquid into gas for transmission into the 350 miles of pipeline between Canvey and Leeds, with branches and spurs to London, Reading, Hitchin, Dunstable, Coleshill, Sheffield, and Manchester. By fire out of solid steel, the methane pipeline was born. Distributed along a 400-mile supply line to dumps set up strategically along the pipeline route. And from the dump to the site. Work started on the pipeline in late autumn 1962. The deadline for completion, October 1963. It would be a long haul, and winter loomed ahead, with such handicaps to men and equipment as rain, mud, ice, and snow. Winter came suddenly, bringing snow and ice on roads and railways the length and breadth of the country. The worst winter for nearly a century, threatening to bring the methane project to a standstill. At Canvey Island, the site of the new methane terminal and jetty, immobilized and silent. Winter in our zoo, where work on the methane project was just a walk in the sun. The site of the liquefaction plant on the coastal plain, like a devastated area, with the urgent work of reconstruction well in hand. What the people of our zoo thought about it was simple. They were for it. Next to the Aswan Dam, it was the biggest industrial project on the African continent. The first commercial liquefaction plant in the world. In Britain, at last, it was spring, 1963. The pipeliners could now press forward across the country. A survey of the route, from pole to pole, by land and water, along a right-of-way negotiated with more landowners per mile than any pipeline ever laid. Strip the topsoil, neatly to one side, clear of the subsoil to follow, and ready for eventual reinstatement. East and west, and south and north, the pipes ride fast, moving up the now open supply lines to the battlefront, from the dumps to the sites along the pipeline. Across the uneven patchwork of Britain, they applied the same spread technique of pipelining, originally designed for endless miles of flat desert. The specialist teams follow each other up, always hard on each other's heels. First, the stringers, who string the pipes along the line. Then the welding team, who bring the pipes together. Steady now. The radiographers photograph selected wells. The films are studied by experts trained to detect the slightest flaw. Trenching. Straight as a die and exact to an inch. Before the pipe is dropped, the welded joints are wrapped in tar and fiberglass, and a final high voltage test to check the wrapping.